Welcome to secondary chemistry. Today we are going to look at the topic of diffusion. And we start off with a shoe and the question, why do we smell stinking things? So even though a stinking shoe might be in a corner of a room, a person on the other side of the room can smell the stinky shoe. So why is this? Everything has to do with particles and can be illustrated using particle theory. So the substance which causes the smell is a gas, and those particles, they are in constant motion, as Brownian motion tells you. If you don't know about Brownian motion, go and watch our video on this topic. And because all those particles move, we can see the phenomenon of particles spreading out. And then some particles, of course, also reach the nose of our girl right here, which is just how do you say, disgusted by the smell of the shoe. So why do we smell stinking things? The independently traveling gas particles are in constant motion. This is Brownian motion. So this means that they will spread out from one place to another. And that's actually what diffusion is. But we can define it more properly. Diffusion describes the movement of particles from a region of higher concentration to a region of lower concentration down a concentration gradient. Okay, what does this mean now? If we have, for example, a certain volume where many particles of a substance are, then particles from there will spread out to fill the room and move to areas with lower concentrations, which means to areas where a certain volume contains less particles. Okay, so I hope you can understand this. And now we want to look at whether substances and other states of matters also diffuse, because that gases can diffuse we have just seen right now. But what about liquids? Within liquids we can also observe diffusion. And why is this? Because there are particles which are free to move. So within the liquid the particles can slide past one another, and therefore they can also, we can say, mix or spread out. Okay, so let me label this. Within liquids we have diffusion, but it's slower compared to gases, because there are attraction forces between the particles within the liquid, which hinders those particles to spread out very fast. This is different in a gas. But how does it behave in a solid? In a solid, we don't even have slow diffusion, we have no diffusion. Because if we, for example, look at this particle, it cannot move anywhere. It's just vibrating at the spot, but it's not free to move. This particle has a fixed position on the lattice, and therefore, solids cannot diffuse. Last but not least, we want to look at the influencing factors of the rate of diffusion. So when does diffusion occur faster and when is it slower? And here we can look at an experiment. You can see a glass tube at the bottom right hand corner, which is closed on both ends with a rubber bung. And we have two pieces of cotton wool, and the left one is soaked in ammonia. So ammonia is a gas, meaning it has one type of particles, namely ammonia particles. And the other cotton wool is soaked in HCl, that's hydrochloric acid, another substance. And these gases, of course, they diffuse, so meaning they are spreading out. And when particles of ammonia meet with particles from hydrochloric acid, then a chemical reaction occurs and we have this wide ring being formed. You don't have to worry about the details. This is a topic for later sessions. But at least you have to know that if these particles, the blue ones and the red ones, meet, they form this wide ring. And what we can observe is that the white ring is closer to the right end than to the left end. And this allows us to conclude that the mass of particles influences the rate of diffusion, because probably, and this is true of course, ammonia particles have a different mass than HCl particles. In fact, the HCl particles are quite heavy, at least they are heavier than ammonia particles, and ammonia particles are lighter. And the ammonia particles have traveled a greater distance than the HCl particles. That's why the white ring is formed closer to the HCl side. And the conclusion drawn from this is that light particles diffuse fast, like ammonia particles. And it also makes sense that light particles can just diffuse and move very fast, whereas heavy particles diffuse slowly. So that's one influence factor, the particle mass, but the rate of diffusion can also be influenced by temperature. So the higher the temperature, the higher the rate of diffusion, because particles are moving faster at higher temperatures. We have also talked about this in the video of Brownian motion. And similarly, it's also true that the lower the temperature, the lower the rate of diffusion is, because the particles are moving slower. And that's already everything we have to say about diffusion. Thank you guys for watching, and see you in the next video.